Hello everyone. Today we're going to be talking about perspective. It's been suggested that ships going over the horizon disappear not because there is a large amount of Earth curve in front of the ship, but rather because perspective means that light coming from the lower portions of a ship is diminished in comparison to that coming from the upper parts of the ship. Well, let's show that this idea is false. We'll consider a building in this case. We'll have an observer and a story of a building at a height y above the observer, and it goes up to a height y plus h, so h is the height of the story. There's an angle delta theta, which is the angle subtended by that story. Let x be the distance between the observer and the building. Elementary trigonometry tells us that delta theta is the inverse tan of y plus h over x minus the inverse tan of y over x. Now we know that tan of a minus b is tan a minus tan b over 1 plus tan a tan b. So we can write delta theta as h over x divided by 1 plus y plus h over x times y over x. And that's hx over x squared plus y squared, where y squared is y into y plus h. At the moment we're considering y squared to be greater than 0, so both y and y plus h are positive numbers. Later we'll consider the case when y is negative and y plus h is positive. That should have tan of that, so delta theta is the inverse tan of hx over x squared plus y squared. Let's just notice that this formula means that as you move away from the building, there comes a point at which the angle subtended reaches a maximum value. If you're very close to the building, that angle is very small, and if you're very far away, it is also very small. Now, the inverse tan function takes values between minus pi by 2 and pi by 2. And it is increasing. So to find out where delta theta reaches a maximum, when hx over x squared plus y squared is a maximum. This is a positive number, and that's the same as saying x squared plus y squared over hx is a minimum. Now that's equal to 1 over h into x plus y squared over x. Now that's equal to 1 over h into square root of x minus y over the square root of x all squared plus 2y. And you can see that thing is greater than or equal to 0, and therefore this attains its minimum. It has a minimum of 2y over h and attains its minimum if root x is equal to y over root x, or in other words, x is y. Now remember, y is just the square root of y plus h, which is the geometric mean of y and y plus h. This result is well known to fly halves in rugby union, because if you want to kick a conversion, then you want to find the distance from the try line that maximises the angle between the posts. Unless, of course, the try was scored between the posts, in which case you'd take the conversion from a suitable distance away from the posts that allow you to get the ball up over the crossbar. Now consider the case where we have y1, y1 plus h, y2 plus h for the relative heights, and there's our observer again. So we have the angle subtended from the upper stories and the angle subtended from the lower stories. So y1 is going to be less than 0 in this case. Now delta theta 2 is inverse tan of hx over x squared plus y2 squared. And delta theta 1 is equal to the inverse tan of hx over x squared plus y1 squared if x squared plus y1 squared is greater than 0, or it's going to be equal to pi plus inverse tan of hx over x squared plus y1 squared if x squared plus y1 squared is less than 0. If x squared plus y1 squared is less than 0, so remember y1 squared we're writing as y1 into y1 plus h, and that is less than 0 in this case. So therefore this sum could be less than 0 if x is sufficiently small. So that would happen in the case that the angle subtended by the story is greater than pi by 2. So now the angle subtended from the upper story is always less than pi by 2. So in this case, delta theta 2 is smaller than delta theta 1. Okay, what if squared is bigger than y1 squared, minus y1 squared, then we know that y2 squared minus y1 squared is y2 plus h minus y1 plus h, and that's y2 minus y1 into y2 plus y1 plus h. And we know that that thing is greater than 0. We know that y1 plus h is greater than 0 and y2 greater than 0. So that product is greater than 0. So x squared plus y2 squared is bigger than x squared plus y1 squared, greater than 0. So hx over x squared plus y2 squared is smaller than hx over x squared plus y1 squared. And because inverse tan is an increasing function, that relationship, or delta theta 2, is smaller than delta theta 1. So once again we find that the angle subtended by the lower story is always larger than that subtended by the upper story. Next, let's have a look at delta theta 2 over delta theta 1 in the limit as x becomes very large. That's equal to the limit as x goes to infinity. Well, we know that as x goes to infinity, delta theta 1 and delta theta 2 both go to 0, and therefore you can get rid of the inverse tans. And that's equal to 1. So we can see that for very large distances, the angle subtended by the upper story and lower story approach each other. In summary, the upper stories always subtend a smaller angle than the lower stories, but at very large distances, the ratio between the two tends to 1. In other words, there is essentially no distortion at very large distances. Now let's go on and look at the equations governing perspective. Let an observer be located at the origin. I'm going to take a plane with a unit normal n. Then the perspective equation is x goes to x over x dot n. All it's doing is saying a point, say x here, you rescale it by a scalar. So x goes to lambda x, and then we're going to require that n dot x primed is 1 if that's x primed. So that gives me lambda n dot x is 1. So therefore lambda is 1 over n dot x. And so that gives me this formula. Let's consider a straight line. In the scene. So that's x is equal to lambda b plus a. where A is a point on the line and B is a unit direction. It doesn't have to be normalized, but there's no harm in doing so. Let b dot n be greater than or equal to 0. We can always replace b by minus b if this is not the case. And let's take a dot n greater than or equal to 0. So I can replace point on the line by any other point on the line. If the line is completely behind the observer, we're not really interested in it because we don't see it. Say there is at least one point which is in front of the observer. Consider the image x primed is lambda b plus a over lambda b dot n plus a dot n. Take lambda equal to 0 to find a point on the line. C is going to be a over a dot n. And now construct x prime minus c. That's equal to lambda b plus a over a dot n, lambda b dot n plus a dot n, multiplied by a dot n, minus a times lambda b dot n plus a dot n. And you can see that those terms cancel off. And so that's equal to theta times b a dot n minus a b dot n, where theta is lambda over a dot n lambda b dot n plus a dot n is a scalar. That's also equal to theta times n cross b cross a. So call that theta d. Then x primed is equal to c plus theta d, which is a straight line. Interestingly, in the limit that lambda goes to plus or minus infinity, you can see that theta will converge to 1 over a dot n b dot n. In which case x primed is equal to c, which was a over a dot n, plus 1 over a dot n b dot n times b times a dot n minus a b dot n. And that's equal to a over a dot n plus b over b dot n minus a over a dot n. It goes to this value here, which is the vanishing point of this line. So in fact, straight lines are mapped to sections of straight lines. Those parts of the straight lines which are behind the observer are not seen, and as we go into the distance, only part of the line up to the vanishing point is observed. What we can say with certainty is that straight lines are mapped to straight lines under perspective. And that concludes our discussion on perspective.